Okay, I think we can start. I just wanted to give a quick intro into OpenZeppelin. My name is Weechi, I'm the events manager. For those who aren't familiar with OpenZeppelin, we're a security company providing products and services in the blockchain space. By working with various startups and organizations in the industry, we're contributing to our mission of protecting the open economy. OpenZeppelin has built products to help teams in the ecosystem build with our open source smart contract library, Defender to automate security operations, and many of you may know us from our work with audits. Overall, our goal is to help you ship faster with lower risk, which leads me to welcoming you to our first workshop on the dangers of token integration. This is part of our 6-session secure development series led by Martin, and hopefully by the end of this session, you'll be taking away some understanding on the risk and common pitfalls of integrating tokens on the mainnet. During the event, if you have any questions, feel free to ask using the Q&A function, or you can raise your hands towards the end and we can unmute you. Martin, I'll let you take the lead.
Thank you, Huchi. Hi, everyone. So excited to be here. I just share the screen and we'll get started with it. So yeah, thank you, Huchi, for the introduction. For all of you who don't know her, she's been like fundamental to get this series going. So thank you for your work. And yeah, the idea is for me to let's talk about the danger of tokens integrations. I've been a security researcher at OpenZeppelin for almost 3 years now, and I've done a couple of audits, to be honest. And I would say that during audits and reading on security incidents that happen in the community, and we in the security community in Ethereum have gathered lots of knowledge around what are the good and not so good practices when we are trying to integrate tokens into smart contracts. And the idea of this whole series of sessions, this is the first one where we are going to talk about the token integration, but the idea is to do this series of sessions around what we call secure development, where ideally you should not only get specifics practices around these different topics, like today is going to be token integration, but the next one is planned to be like strategies for secure access controls, or dangers of integrating with price oracles, which is a hot topic today in the ecosystem, and many more, right? So regardless of each particular token, each particular topic, I would say that the idea of this series of sessions is to share with you kind of the mindset, right, that we have when we are code reviewing, kind of the mindset that we use when we are doing an audit or when we are trying to find flaws in smart contracts. So I would highly encourage everyone to join me in many of the sessions that I will be leading. Again, each one will be like self-contained, and each one we will talk about a specific topic, but the recurring thing will be like secure development and which are the nice practices that you can start integrating. And by the end of the series, hopefully you will get like a better mindset and understanding on what are the good practices or what are the things that you should be thinking about when you are code reviewing in your projects, right? You won't become an auditor after the series, but hopefully you will have a better mindset when it comes to thinking about security and being perhaps a little bit more paranoid. When we talk about DeFi and smart contracts, I would say that composability is usually a big word that comes up. And composability is super important, right? Because we are building this open economy in which we have these systems that talk to each other and that integrate with each other, and that is great. And I'm super in favor of that. And I think that we should all be contributing to that to happen. But let's do that securely, right? We should be assuming like there are risks of doing that. There are assumptions that people make when we integrate with different projects. So, and we should be at least at the very least, we should be aware of that. We should know that when we talk to another project, we are introducing some risks, we are making some assumptions, and many people that join the ecosystem might not be aware of them, right? Remember that the ecosystem is growing, we are onboarding new developers, new auditors, new professionals and enthusiasts into the space, and that is awesome. But perhaps those who have been a little bit longer in the ecosystem know some things that others don't. So we should be aware of that, and we should be trying to share with each other what are the risks, what are the assumptions, and what we should be taking into account when we talk about composability. But today the specific topic is token integration. And in that sense, I believe that at least in DeFi, it's pretty obvious that if you're building a DeFi project or a similar one, you will be talking or you will be using tokens that perhaps you didn't code, that these are tokens that some other people coded at some point. And I want to share with you many insights and practices and things that you should be aware of when we compose our systems with different tokens. So I want to give you a little exercise first before we get started. Let's do a quick code review, right? I will give you like between 1 minute and 2 minutes, let's perhaps 1 minute and a half, in which you have this contract. This is Solidity code. If anyone is not that familiar with it, you can read line by line, and the idea is for you to take notes, right? I will give you 1 minute, 1 minute and a half. You read it line by line and take notes, and or just mental notes, or write them in a piece of paper, whatever you want. You won't need to share them afterwards. It's just for you. You can, if you want, you can send them to me. But the idea is take notes about things that you might seem suspicious in this code, right? Go line by line, take down notes about any problems, questions, issues, vulnerabilities, anything that comes to mind when you read this piece of code. I will give you, 1 minute and a half, and then we resume the workshop, and we will compare notes about this piece of code. And I will just like enjoy the silence now. Let's do 30 seconds more. I like this. Cool, perfect. Obviously, you may have found many things or just one or two, but the idea is to do that kind of exercise, right? Is to ask questions about the code that we review. And I want you, the first thing that I want you to think about is asking questions when you're making a code review. We auditors tend to ask lots of questions, from the very silly ones to the sometimes smart ones if we're lucky. But the mindset is, okay, we have a piece of code, read line by line and ask questions. Be paranoid about it. Don't trust what you read. Try to think outside the box a little bit and try to see what's beyond what you read. So some triggers, right? These are just some initial triggers that some people may have noticed or not. So the first one is, does this code even compile, right? Because I don't know if somebody took the time to actually wrote it down and compile it, but it might be the case that in some Solidity versions, it doesn't even compile this piece of code. And the second question could be, okay, but what Solidity version are we talking about, right? Because if you saw the code, well, I didn't tell you what Solidity version you were looking at. And depending on which Solidity version, it might be the case that, for instance, the arithmetic operations that you see at the bottom of the code might overflow or might not, depending on the Solidity version that we are talking about. Obviously, the code doesn't have any docstrings. So that means that we cannot even start code reviewing it because we don't know what the code is supposed to be doing. And that is a problem that we auditors face a lot. What if I told you that this piece of code is actually meant to be an implementation contract of an upgradable system? Then it doesn't even work, right? So if you don't know what a piece of code is supposed to do, and if we don't have the documentation, if we don't have like a single comment, doc streams, whatever, telling us what's the intention behind the code, what is this code trying to do, well, it might be complicated to even do a code review, right? But following the line of thought, well, there are no functions to withdraw tokens. There are no visibility on state variables. Is there a problem or not? Perhaps there are no events. Should we be monitoring this contract? If there are no events, we probably won't have a hard time. We will have a hard time doing that. We are assuming some previous approval of tokens to this contract. Might that be a problem or not? There might be a reentrancy. In that case, if there were further functions, for instance, to withdraw tokens, there might be a case of a reentrancy that we could again exploit. So again, and these are like initial triggers that may come as we review line by line this code. And it might be the case that you even found things or you were asking questions about things that I didn't even mention here. And that's interesting. But the main one that we want to talk about today is, does this piece of code work with any token? What are the behaviors that tokens may have when we are doing that token.transfer from blah, blah, blah? What are the considerations that we should be having in that single line of code? And that is interesting because you can see lots of projects with that same line of code, right? And we should be starting thinking about, okay, what are the risks of doing that? So let's begin with it. The idea, again, is having this what if mindset of things that we might not expect. And the idea is, okay, let's talk about these things that we may not expect. So first one is, some tokens can block addresses. And that's pretty well known already, but some people might not be aware of it. So in the case of USDC and also of USDT, there is an admin that can block addresses, which means that the address won't be able to transfer tokens or won't be able to receive tokens, or even like perhaps won't be able to approve tokens. And probably there are others, right? Today I will mention some of tokens, which are the well-known ones, but probably there are hundreds of tokens out there, thousands, I don't know, that implement similar functionality that we should be aware of. So we're just going to focus on a couple of ones. So these two, for instance, have an owner that can block addresses, and even if your system of a contract or a contract in your system at some point gets blocked, it might be the case that your system is at a risk, right? Because, for instance, let's say that the owner gets compromised and it starts blocking different DeFi systems. What would happen? What would happen to the funds in your system? How would your team react to that kind of scenario? Are you even monitoring for that? So we should be thinking about these kind of things. And I will mention in this talk many of these kind of risks, and the mindset will be always the same. Are you prepared to handle this? Are you thinking about this? Are you documenting these kind of assumptions? Did you even know about these kind of risks? So let's continue, right? Because there are tokens that can be paused. And again, USDC, USDT, VNT, and many, many others. I'm not against like pausing. I'm just saying, let's be careful with it because there are tokens that can do this. And that might introduce risks in your system. And so these tokens have this pause function or similar that may prevent transfers or may prevent approvals, so that might lock funds at some point and so on. There are tokens that, this is a very interesting topic, that have send and receive hooks. And by hooks, I basically mean that the token can call, for instance, the sender or the receiver of the transfers and might do something with that. So we have pretty well-known standards so far that are the ERC 777, ERC 721, which is the NFT, ERC 1363, and probably there are many more, right? So let's just focus, for instance, on the first one. In ERC 777, in a transfer, you will see that the token will call the sender, will modify the balances, and will call the receiver. And that might be good in some cases, but in other cases, that might not be so good. Such as in this contract. This is a very simplified example of a vulnerability that was attacked last year to steal millions of dollars, in which we see, again, a very simple, very simplified example. But there are two functions, supply and withdraw. The function supply will allow us to deposit a token and will track the internal balance of that token deposited for the caller. And the withdraw function should allow anyone to withdraw the tokens that they deposited in the first place. But if we introduce an ERC-777 into this contract, there might be a big problem, and an attacker might be able to execute a reentrancy attack and trick the internal accounting of the contract and even steal money in some way. And if you want to read more about it, the IMBTC hacks were interesting in this regard, and also Uniswap V1 had this funky behavior in which they weren't handling ERC-777 very well, and Consensus had reported it, and then we at OpenZeppelin showed a proof of concept of that. So that's for the tokens that have these hooks, which are interesting, and you should be careful when you integrate with them. There are tokens that prevent transfers, and I'm not saying like that this is on its own is risky, on its own or on its own is bad, right? So there are tokens that won't allow you to transfer tokens to the token contract itself, or won't allow you to transfer token to a zero address or to the caller's address, or won't allow you to transfer zero amount of tokens. Again, different behaviors for different tokens, so you shouldn't assume same behavior for all tokens. That a token is an ERC20 doesn't at all mean that it will behave exactly like another ERC20. And that applies also for other standards as well. So again, in this case, different cases for Link, for the OpenZeppelin ERC20, for composite tokens, for BNB, they all have different ways of handling these cases. I would say that not allowing transfers to a zero address might be already a kind of de facto standard, but there are tokens that still don't implement that and follow other behaviors. Continuing, there are tokens, this is again another interesting topic, tokens that take fees on transfers, and even tokens that may take fees on transfers, that they don't do that today, but they have the ability to do that, such as USDT. And below we have STA, which is a token that was used to steal some money from balancer pools. And I think that last week or this week, I don't know when, recently on Binance chain, there was a similar hack using a token that would take fees on transfers. So what's the problem in here? The problem is that some tokens might take a fee on transfer, which means that you won't receive what you think you will receive. Or instead of taking that fee and sending that to an owner, they will burn that fee. So in this case, for example, it might be the case that you have this deposit function and you think that you will receive, I don't know, 100 tokens, but you actually receive 90 tokens. So the internal accounting of your contract might be incorrect and can be corrupted at some point. And that would mean that your system might have, I don't know, financial losses, or somebody might be able to trick or the business logic of your contracts. So super careful with this kind of tokens. But let's see then, given it's a kind of a pressing topic, seems to be today in the community, let's see how other big players handle this, because they are already aware of this, right? So in the case of Uniswap, given the architecture that they have these periphery contracts and these core contracts where the periphery talks, you talk with the periphery, I mean you by the user talks with the periphery, and the periphery talks with the core contracts. In the periphery, you will find the add liquidity function, and in the core contracts, you will find this main function. And it's interesting to notice that the periphery contracts will transfer from you as a user to the core contract, which is the pair. And then we call the mint function. But if you notice, the mint function doesn't take any amount as a parameter, right? The mint function only is checking how much it received. That's only it does. It's checking what is its balance right now. So it's just accounting for what it actually received. It doesn't care what it was supposed to be sent. You just care about what you received. And that is safer than the previous example that I showed you. But that's not only the case for the Uniswap. We can look at how Compound does these kind of things. So in the case of Compound, down the chain of calls that you will find when you deposit an asset into Compound, you will find this do transferring function. In it, we can see briefly that first the function will check balances before the transfer, then the function will execute the transfer from the depositor to the contract. Then we have this piece of assembly, which is kind of magic. I won't dive into it now. We can see it later. But we see in step number 3 that the contract will check the balance after the transfer. And finally, the contract will just account for the difference between what you deposited, what the balance that it had at the beginning and after the transfer. And that's the only thing that matters, right? What you had, the difference between what you had before and what you have now. In that way, you can protect against these tokens that may take a fee on transfer at some point. And again, we see Uniswap and Compound, which are two pretty well-known protocols in the DeFi space that are already taking care of this, right? So you can actually see their code, read their code, and learn from their practices to make your system more secure or more robust. Continuing with different behaviors of tokens. So this is a pretty well-known one probably, but important still. Tokens have different ways of signaling failure and success. And depending on which token you are interacting with, it might be the case that they revert on failure, or they return false on failure, or that they do something different from that, honestly. So we see the case of SCRX that they only return a Boolean, true or false, depending on success or failure. We see BNB that the transfer from function will return a Boolean, but the function transfer won't. We see USDT that the function transfer won't return any Boolean. We see Gold Tether that also had its behavior that apparently only returns false in all cases. So different ways of handling this, right? Again, and they might be all ERC20s in some sense, but even these kind of things, they handle differently, and you should be ready for that. So how can you be ready for that? Well, you can use wrappers. The idea of using wrappers around ERC20 operations is having a more consistent behavior across all tokens that your system handles. So in OpenZeppelin contracts, we have this safe ERC20 wrapper that you can start using. Is a library that you can directly import, and you can use this safe transfer from, safe approve, and so on, functions that will give you like a more consistent behavior across transfer operations and approval operations of ERC20s. And it's there you have the link to the documentation. You can start checking it out. You can import in your contracts, and you should start using it now. More behaviors of tokens. So some tokens can be flash loanable. This might not be, let's say, a behavior ingrained in the code of the token, but we should be careful with them as well. Because some tokens can be living in a pool, such as, I don't know, a Uniswap pool. We shouldn't assume that some account cannot have like a super large amount of tokens. So we should be testing for like extreme values, such as in our deposit functions or swap functions, withdrawing functions, and so on. Any function that handles tokens, we should be aware that the amount that we receive could be extremely large, absurdly large, and we should be ready to handle that, and we should be testing for that kind of extreme scenarios. In some cases, we can use token snapshots, which can help us prevent attacks using flash loans. And for instance, it's sometimes can be seen in governance contracts, such as in the governor contract from Compound, which is the snippet that you see in there. That what they will do, and this is already, I think you can see it also in Uniswap governance and others, that they actually take the amount of tokens that the caller had in the previous blocks. And that means that you won't be able to, I know, take a flash loan of comp tokens and trick the governance system, right? So that's an interesting case, and you can again see what is the right answer sometimes in code that the community has already published. And talking about flash loans, now we also have flash mints, which again a similar scenario, but not only we should take into account that tokens are living in a pool and can be flash loan, but also tokens can be created out of nothing in a flash mint. And in this case, we have now DAI that an account can have up to 500 million DAI in a single call, just because of a flash mint. And we have even implemented that functionality in OpenZeppelin contracts as well. So I think that little by little, it will become more popular. So don't make the wrong assumptions about the amount of tokens that some account can have. Test for them, introduce this kind of behavior in your test suite, and I'm pretty sure your system will be more robust. And on the same line of thought, similar to what I was saying, I think that it's important to note that, again, tokens may have a huge total supply. We don't know the new token that's going to come out, what kind of behavior it will have, and huge total supply might break interoperability in some cases. This is just a snippet of code from the Uniswap V2 pool, in which you see that the pool won't be able to handle that much tokens, and that limit is actually imposed by their use of a fixed point math library that won't be able to handle larger numbers of that. I mean, it's a pretty large number, right? But depending on how the token is coded, we don't know the next token that's going to come out. We should be careful, and we should know the kind of limitations that we might be hitting at some point, and these behaviors that may break interoperability within this composable world that we are trying to create. Very well, continuing. Another one. So we have tokens that can modify accounts balances, and that's also an interesting behavior to note. And I mean outside transfer operations, right? So that means that, for instance, let's say I send some tokens to your contract and I deposit in your DeFi protocol, and I deposit 100 tokens, and without any kind of transfers, it might be the case that tomorrow the balance of your contract is actually 110 instead of 100. And that's because some tokens update the balances automatically. Depending on which token we are talking about, they have their different reasons for doing that. I won't get into the details, but the idea is, remember, there are special tokens that have these special behaviors that can modify account balances outside transfer operations. So it might be the case that if you are not doing this right, the internal accounting of your token contracts might be outdated at some point. So you should be perhaps, I don't know, querying more often these token contracts and update your internal balances, or even like you can reach out to the people, to the communities around these tokens, and probably they will give you better answers on how to best integrate them into your protocols. But again, something to take into account. We can continue going. There are tokens. I mean, this is actually an very edge case, because I haven't found a token that follows this behavior, but it might be the case, right? Because if you read the ERC20 standard, it doesn't say that the function's decimals, name, or symbol are mandatory, right? It says you must not expect these values to be present. Again, I don't know why anybody would code a contract that doesn't have these functions, but well, it could be the case, right? So you can see a snippet of code at the bottom of the screen from UMA, and what they actually do to tackle this case is, for instance, instead of just directly calling the decimals function of a token, what they do is they include in a try catch, which you can use in Solidity, right? So you try to call the decimal functions. If something happens, for instance, the token doesn't have a decimal functions, they assume that the token will have 18 decimals. We can start discussing whether that's the right or wrong assumption around whether the token has 18 decimals or not. But the idea is, it might be the case that at some point you should be careful with the assumptions that you make around the functions that ERC20 contracts implement. Again, I haven't found any contract that doesn't include these functions, but it could be a case, who knows? Talking about decimals, there are tokens that don't have 18 decimals, right? Nobody's saying that tokens should have 18 decimals, and probably nobody should be blindly assuming that. It's usually the case, yes, but there are well-known tokens, for instance, such as USDC, that doesn't have 6 decimals. And that means that basically one DAI, in this case, that does have 18 decimals, is represented with 18 zeros. USDC is represented with 6 zeros. And we have other cases. We have DAI USDC, as I was telling you, but we also have YAM, we have C tokens, we have WBTC, and they all have like different amount of decimals. And if you're building a DeFi project that it's integrating with this kind of tokens, you should be careful with that, right? Auditors listening to this talk probably may have found already some issues in projects that were not aware of these differences between decimals and tokens. And again, you can see how well-known or real players in the community are tackling this kind of problems. And you can see their code and you can see how they interact with tokens so as to being able to handle tokens with different amount of decimals when they are, I don't know, doing calculations, internal calculations for their DeFi protocols. So again, be careful, don't blindly assume 18 decimals, there are other cases as well. This is becoming a de facto standard, I would say by now, that many tokens have this infinite approval. And by infinite approval, I mean that you can approve a maximum amount of tokens to a contract or to an account, and that amount of approval won't be decreased when you execute a transfer from. For instance, you can see that there you have the snippet of code that if you approve the maximum amount of DAI to an account, that amount will never be decreased, which is fine. And I think it adds to user experience, and it's better usually for dApps, so that sometimes you don't need to be constantly moving the approval. But for instance, you can see OpenZeppelin ERC20 contract that doesn't have that kind of behavior in the function. It doesn't necessarily mean that one is good nor bad. It's just, let's be careful that different tokens have different, even for approvals, different behaviors. Speaking of which, we have this well-known already, it's kind of old attack in the ERC20 standard, which is called the allowance from running attack. Probably most of the people here are aware of it. But again, there are different functions, non-standard functions that tokens may have to solve that problem, such as the OpenZeppelin contract, the ERC20 contract in OpenZeppelin contract, that have these increase allowance and decrease allowance functions. And others try to solve that in another way, such as USDT, that will disallow approvals when the approval to an account is already positive. And actually, I think I recently read a pull request in the Uniswap V2 repo, if I recall correctly, in which this could be problematic. Like this kind of behavior wasn't taken into account in the dApp that they were building, and it introduced some kind of weird behavior for the users. So again, be careful with these cases. This is a simpler one. But monitoring, I would say, it's starting to gain traction in the community, and I think people are becoming more aware that monitoring is super important in your contracts. If you are not doing monitoring, please go check out Defender Sentinels that you can set up your own monitoring system. But in this particular case, there are tokens that may not emit the events that you expect them to emit. So if you are building monitoring system, for instance, to see the balances of your accounts or to see how transfer of tokens happen. And there are tokens that implement different events, such as the one that you would expect. So for instance, in the case of this mint function, they are emitting a mint event instead of emitting a transfer event from the zero address to the account that receives the tokens. Or in the case of the burn function, they are emitting the burn event instead of a transfer event. Not necessarily bad, not necessarily a security issue, but may introduce behaviors that you are not expecting in your monitoring systems, and you probably should take them into account. And well, I told you all of that, but the reality is they are upgradable tokens, right? And so many of the things that I told you can change. Without you noticing, perhaps, right? And can change immediately. So many of the behaviors we just saw in many of the tokens that I mentioned can change tomorrow, can be changing right now. The question is, how are your system is going to be prepared for that, right? And I'm just going to mention a few, but I believe that there are more and more upgradeable tokens, and I'm totally in favor of upgradeability. And I think that it has solved many issues, and it has given the possibility to developers to roll out new features and fix bugs in very cool ways. And I think that upgradeability is something that is here to stay, and more people are going to implement it. But just be careful in that the tokens that you might be integrating into your systems can be upgradable. USDC is a case, TUSD, UBI, and probably many others, right? This is just like 3 very basic examples of upgradable tokens. And I'm mixing here different tokens just to mention that the mechanism through which these tokens are upgraded might be completely different, right? Some tokens might have like a very centralized fashion in which they have an owner, and that owner is, I don't know, completely allowed to immediately change anything about the token and trigger an upgrade, which could be fine, may have their use cases. Other tokens may have an upgradeability mechanism that should be triggered, I know, by a full-fledged open governance system that the Ethereum community is controlling. So we have like a huge spectrum of different mechanics for upgradeability, and that is totally fine. I'm just saying that when you're integrating this kind of projects, this kind of tokens built by these projects into your system, you probably need to be aware of that. You probably need to be aware of how people are solving upgradeability, what kind of upgradeability patterns they are using, who controls the upgradeability of the tokens, who has the keys basically to trigger these upgrades, how are you going to answer when the token is upgraded? Do you care? Do you not care? I mean, it's fine if you don't care that USDC can be upgraded, right? But at least be aware of it, like make a conscious decision about it, and perhaps even like document something in your code saying, yeah, we are integrating with USDC or USD or whatever upgradable token out there, and say that, well, you are aware that they can be upgraded and you will do nothing about it, which could be fine. I'm just saying that you should be aware of it, and you shouldn't think that tokens are this magic immutable piece of code that behaves nicely and you can easily talk to. Many of the integrations that you see today in the ecosystem are just that you see, for instance, announced in Twitter, probably have lots of thought behind them, right? Behind the scenes that you're not seeing, of people thinking about these kind of things and trying to solve these kind of problems. I will just show you one. For instance, you might need, in your case, only allowing interactions with known implementations, right? This is a snippet of code, I think, from a maker contract, in which they are basically holding a mapping of known implementations that they know they can interact with, and they know they have reviewed, and they are safe to some extent to interact with. And if they know a new implementation, when the token is upgraded, they won't interact with it. They will just go through perhaps a governance. I'm not sure about the mechanics, but perhaps through a governance mechanism in which they can allow a new implementation, right? So it might be a case that in your system, you want to start thinking about something like this. I'm not saying this is the right solution and this is a silver bullet. Again, for each project, probably there will be a different answer, but these are just some triggers for you to think about. And we haven't even discussed economic risks, right? So tokens are this kind of, on one hand, piece of code that you can read and that you can analyze from a technical standpoint, but also they have economic value sometimes, right? Sometimes they are worth something, and that changes pretty much. But introducing a token into your system can also introduce economic risks to your system. The code of the token can be perfect, can be audited, can be super polished and clean and tested and so on, and comply with every single standard out there, but may have like, a very high price volatility, right? And that might introduce economic risks to your system. So you probably need to have somebody in your team Thinking about that, thinking about how the economic risks of your system play when you start integrating with different kind of assets. So it's super important to be thinking about that, and I think that in recent events, I won't mention names, but you can probably read them online. There have been many cases of protocols failing just because they were integrating with a token that suddenly dropped 100%, 200%, or completely to zero in a couple of hours. And you should be careful with that. I think that it's important to know that. It's important that DeFi systems are not only like this kind of coding solidity and that's it. There are many economic incentives around this, and you should be trying to tackle that as well. I know might be a lot, but I'm just trying to be honest. So some closing thoughts. I'm just wrapping up here. It's important to have a zero trust mindset. I would say that first thing is thinking that tokens are arbitrary code, that they were coded by a person on the weekend doing, I don't know, drunk and doing absolutely recklessly coding. So don't trust them, right? The idea is for you to be able to verify that. Go ahead and read their code. Try to see how they behave. Try to see where that plays nicely or not with your system. Try to have safeguards if the token might do something to your system, right? So zero trust mindset, and try to then like verify and grow your trust based on actual facts and not on, I don't know, a Twitter announcement that you just saw. Have a healthy distrust-free standards, and that means that I have showed you many cases in this presentation that many are like ERC20 standards or ERC20 compliant tokens, but they behave differently, right? So first, distrust them. Don't believe that an ERC20 just behaves nicely. Try to see how they actually behave. Many projects might benefit from having a list of allowed tokens. I'm not saying that's for everyone, because you may have, I don't know, a fully permissionless system that anybody can create pools out of different tokens. And well, it doesn't need having an allowed list of tokens, but it might be your case, right? So if that's your case, which could be, and I've seen many cases similar to that, so try to verify the behavior. Try to have, I don't know, it can be on your own if you are the sole owner of your system, or you can have a governance mechanism through which you can verify behavior, analyze economic risks, and try to allow tokens progressively and not every token just recklessly because you like it. So consider having that kind of mechanism into your system, and I have seen many DeFi projects having that, and it's perfectly fine to have that, and people are doing this. Number 4 is obviously see how experienced players do it. I mean, the DeFi ecosystem, while I personally believe that it's still in its infancy, there have been people in here building awesome things from a couple of years now. And we can learn from their code, right? I'm not saying like fork it, copy paste it, at least try to respect their code, their licenses, and so on. You should be complying with that. But try to learn from them, try to speak with them, try to speak with their community, see how they do things, see their practices, see how they solve the problems that you're solving now, because it might be a case that somebody has already solved that problem and you don't need to reinvent the wheel. So in this presentation, we saw some cases, right, from Compound or from Uniswap and from others that have already solved some of these problems that you might face. And you can actually talk to them and see how they do it, and you can learn from them. And last is documenting your trust assumptions. Your users will like it. Your new developers in your team will like it. Your auditors will like it. I believe that having more documentation around the things that you are assuming about the systems that you integrate with is fundamental. And it will make your job and many people's jobs in the community easier. So try to do that, right? Try to have documents around the kind of things that you are assuming. The reality is that many of the things that I told you, I haven't invented, right? The security community has been super proactive trying to push for awareness in this sense. So here you have many different links that you can start checking out. They are not from OpenZeppelin even, that you can see many of the behaviors that I mentioned you today in these links. Perhaps you need to do some mixing and matching, right? And not everything is everywhere. And this presentation is also another building block in that sense. So it's there, you can check them out, you can see how they do things, the kind of things that they recommend, and you will see many patterns. And I think that again, the security community has been super proactive in this sense, and you can start talking more with everyone in security. So today we have seen like the dangers of token integration, right? The idea is, again, we will have multiple sessions around this. We will have sessions on strategies for secure access controls. We'll have sessions on integrating with price oracles and many more. You can actually leave feedback on kind of things that you want to see in these sessions. Again, the recurring topic will be secure development. And in the meantime, the idea is for you to go to Defender. In Defender, you will find this component, which is called Advisor, in which we have lots, and honestly, lots of security best practices around secure development that you can start reading now. You can sign up to Defender, it's free. So you can read them, you can learn from them, and you can start integrating those other practices into your project. Again, not everything is about integrating tokens. There are lots to security. We have just covered the tip of the iceberg, I would say. So there's this advisor, and you can check it out, and I highly recommend you reading that. I have contributed personally some practices to that, but many people at OpenZeppelin have dumped many of their ideas and recommendations in there. So super, super, super recommended for you to check them out. So I would say for today, that's it. We have some time for Q&A, questions, comments, impressions. You can find me on Twitter as Tincho Abate, also in Telegram. There you have my email if you want to reach out to me. We have Defender. You can check out our blog where we also post our security audits and many other material that's going to be interesting for you. And if you want to start any kind of discussion with the community, you can head to our forum, forum.openzeppelin.com, and we can continue chatting there. So that's it. Thank you very much.